Final exam review question 82. Assume that the mean length of a human pregnancy is 268 days with a standard deviation of 9 days. What percent of human pregnancies do we expect to last 260 days or less? Let's start by assuming that the number of days of pregnancy is normally distributed. I'm going to sketch a normal distribution. We're given that the mean is 268 days and the standard deviation is 9 days. And we're asked what percent do we expect to last 260 days or less. Well, 260 days is to the left of 268 somewhere. So we're going to be looking for the percent of area that the shaded region represents relative to the entire curve. Now, if you remember, the entire curve represents 100%, so we're going to be looking for what percent this is. Since there is an infinite number of normal distributions with an infinite number of means and standard deviations, to find this information in a table, we'd have to have an infinite number of tables, which of course is impossible. So we take this normal distribution and transform it into what's called a standard normal distribution. In the standard normal distribution, if you'll recall, the mean is 0 and the standard deviation is 1. So in our case, the 268 will be transformed into 0, the 9 transformed into 1. We're going to have to figure out what the 260 is transformed into. And we do that with z-scores. A z-score is the data in question, which is 260, minus the mean divided by the standard deviation. What this tells us is how many standard deviations is the 260 away from the mean. We'll let our calculator compute that for us. Two. 260 minus 268 divided by 9. Let's make sure that's a decimal. Negative 0.89. Approximately negative 0.89. So our 260 in a normal distribution will be transformed into negative 0.89 in the standard normal distribution. Again, we're looking for the area that this shaded region represents. To do that, we need a table that gives us information about negative z-scores. This particular table gives us the area under the curve to the left of a negative z-score. In our case, the z-score is negative 0.89. We look at our z values, find negative 0.8, which is right here. We scan across till we get to the 0.09, so we're now at negative 0.89. And we see 0.1867. 0.1867 represents the area of this shaded region on both curves. So the 0.1867 represents what proportion of the area under the entire curve is represented by the shaded region. Now we'd want that as a percent. To change the 0.1867 to a percent, we know that's 18.67%. Move the decimal place 2 places to the right. So 18.67% represents the percentage of pregnancies we expect to last 260 days or less. The next part asks us, if we have 125 patients, how many deliveries are we going to expect in 260 days or less? Well, we know 18.67% of these pregnant clients will deliver in 260 days or less. So if we take 125 times the 18.67%, as a decimal, of course, that will give us how many pregnancies we can expect to deliver in 260 days or less. Again, we'll let our calculator do that for us. 125 times 0.1867 gives us 23.3. Obviously, we can't have 0.3 deliveries, so we'll round it down to 23 deliveries. The 23 tells us that of the 125 patients we have, expecting 18.67% of them to deliver in 260 days or less, we should be delivering about 23 babies.